Hi, math lovers. Let's talk about notes number 7 today. We're going to talk about exponents and the quotient rule. So maybe this is a little bit of a review for you. That's fine. Maybe you were absent the day that you learned it and you were never really sure, but let's just go through it real quick, give you a good overview. Everything's going to be based on this today. So anytime we have a negative exponent, it's like the base is saying, hey, move me to the other side of the fraction. So it's currently in the numerator and it wants to get moved to the denominator. Once it gets to what it wants, it puts its hand down. So we have 1 over a to the n, okay? So using our example in a, we have 4 to the negative second. So it's saying, hey, I've got a 4 as a base and a negative second. I'm going to move to the denominator of a fraction. And you see I did that here with 1 over 4 squared. Okay, and then of course simplify it. And then we can spice it up by putting a negative sign in front of that problem once we finish it. So it's going to be negative 1/16. I've did a couple of these. I'm going to just show you real quick. In part C, where I have the negative exponent, everything in the numerator is going to drop to the denominator. Everything in the denominator moves to the numerator. So here I've got 5 to the third over 2 to the third. You notice here how we did the switcheroo. Numerator becomes the denominator, denominator becomes the numerator, and it all moves. Okay, be sure to also simplify it. Good old-fashioned in letter D, good old-fashioned exponents there. There's nothing much to do there. But look at E. Look at this. Only the negative appears on the Y. So the X stays there as is, okay? We can move into the quotient rule, which means we're going to subtract our exponents. You guys know this one. You wouldn't have gotten to me if you didn't know this one. So you can see in A, I'm going to go ahead and I'm going to subtract the 5 and the 2 to get the 3. This one's a little more exciting because, oops, I went right over the answer. In B, what you're going to do is you're going to subtract the 5 minus and now subtract the negative 8. So that you're going to get a positive 13. That's a fun problem. I like that one. In part D, in this one, in part D, I just wrote it all out so you can see every single term just dropping out, which really all you could do is you could take that, those R's, you could do 7 minus 9 and you have negative 2, and that leaves the R squared in the denominator, okay? We could also use rules for exponents where we're going to just distribute in, this 2 gets distributed into the set of parentheses like we did in the last lesson. Then it starts to become a little bit more confusing. And if you are not somebody who writes things down, this is where you're going to get started writing things down. Whether it's notebook paper or it's the chalkboard, writing it out. What I like to do, I'm going to switch to a different color here. I like to identify the negative exponents, and those are the terms, if you could see them, that are going to move, okay? You're going to take these terms here. Oops. Well, look at that. I got a highlighter. You're going to take these terms here with the negative exponents, and they're going to go ahead and they're going to move to the other side of the fraction. So I like to move those first. This is the method. Over here, this is the method that I like to use. I would move the negatives to the denominator negatives to the numerator, and then I would go ahead and simplify, but that's totally up to you. You know, however you work best, that would be fine, okay? And then this last one, this is just so much going on in it. First thing you're going to do is take this negative 1 and distribute to both sets of parentheses. Take the negative 2, distribute to both sets of parentheses. And you can see here how I expanded the whole thing out. Nice and neat. I'm going to then go ahead and add my exponents if they're the same. So 3 to the negative first and 3 to the second becomes 3 to the negative third. And then I take care of my x's. From this point, then I'm going to take the terms that are I'm going to take the terms that have the negative exponents, O, which that's all of them, and bring them to the other side of the fraction and clean them up. I have more notes, number 2, number 7.5. Give me just a second. I'll get that up. Okay, so I'm back with more exponent notes. Here we're going to work through fractional exponents. And so fractional exponents are a little bit different. I'll show you how I write them. I'm going to write them. I'll just get some little spot here. So anything that's raised to a fractional exponent is going to be, like I have here, power over root. Okay. You're going to take whatever you have. So say I have 4 to the 1/7 power. Okay. That means that 1 is the power on the 4. So 4 to the first. And then I'm going to have root here with an index of 7. You've done indexes of different numbers. That means that's how many in the set I have to get the number to break out of the root. I mean, so often you spend time with square roots, and every time you had a square root, you know, you didn't write an index in there. So you had the square root of 36, but it was understood that the index there was 2. And that means you had to have 2 sets of them. So suppose I have the cube root of 27. That means that it's going to be the cube root of 3 times 3 times 3. I need 3 of them for them to come out from underneath. And that answer is just going to be 3. This one here is just going to be 6. Okay. So just taking a look at how I wrote these, I wrote this to the 1/2 power. That's the same thing as 36 to the 1, and then the index here of 2. I personally like this method better. I'm thinking about 36. I can rewrite 36 as 6 squared, and then the power to a power 2 times, I could just go ahead and multiply my exponents. 2 times 1/2 is 1, and I'm just left with plain old 6. Isn't that beautiful? Okay. Same thing over here. This is the method that I prefer. I know that 100 is a perfect square, so I rewrite 100 as 10 squared. And I raise that to the 1/2 power because that's coming right from here, coming right on down. And so power to a power, you multiply, and that becomes just, you know, -10. So there are lots of practice with these where it's like they set the numbers up on purpose, obviously, because they are so absolutely beautiful. Let's see, F. Let me go back here. Example 7. Hold on. Let me go to example 8. Load it up here. Okay. So this next set is how I like to do the problems. And you can see I took all of the numbers and what I knew about their bases. Like every time I see 32, I think 2 to the 5th. Every time I see 125, I'm thinking 5 to the 3rd. Every time I see 27, I'm thinking 3 to the 3rd. Every time I'm seeing 81, I'm thinking about 9 squared, or I'm thinking about 3 to the 4th. And then they go ahead and they reduce. I have a feeling that many of you are just going to go ahead and grab your calculator and put those in. And it's just fine. You're going to get the answer. But to be honest with you, you don't really understand where it's coming from. And that's what I want you to do, is to really know the derivation of all those terms. Okay, moving on a little bit further to example 9, which I think is gosh, a boatload of fun here, is you're going to go ahead and simplify these. Now, some of you, like I said, might put it into your calculator, but look at how this problem that is so complex just kind of all falls apart. So I can take this highlighter. There we go. We can take this 27 to the 1/3 power and rewrite that as 3 cubed. Notice that power to a power are going to reduce. Then I take this 27 to the 1/3 power, I rewrite it. And isn't that beautiful how the numerator is just going to fall apart? I do the same thing with the denominator, right? 27 is 3 to the 3rd. And I have 3 to the 9th because, again, power to a power, you're going to multiply. I then reduce, and I'm left with my final answer of 1/27. There are a couple more that you can look at. I think you should have some fun with your problem set.